Hey everyone, welcome back to the Gantry Robot project. We have made some progress since our last video and have developed some control software along with a simulation of the workspace. This video is relatively software heavy with a little bit of hardware in there where necessary. Let us know which format you prefer.
So in this video we're going to look at testing the joint limits, writing the control software, getting the gripper activated, simulating, it's basically just a graph of the workspace, and then wiring up some control inputs, so some potentiometers. Last time we said that the first thing we needed to do was to test the joint limits, and the way we did this was to wire up some linear potentiometers as inputs for the servo motors and then split up, so Ethan was sat at the computer and I was sat with the robot, and we could increment the potentiometer through its sort of length and see where the robot was moving, and when it got to a point where it looked like it was going to touch, we could wire it, we could code in a hard stop.
We found the upper and lower limits of link 2 for each position of link 1 in 10-degree increments. Here's a snippet of what it looked like. And then this is... So is the snippet of what it looked like for is that a video? Or?
Yeah, that's it. That's going to be it overlaid on the screen, and then us just looking like this in the background. No, we'll probably use full screen that bit.
And then this is where we ended up. This table here, which has every single link 1 value and its corresponding link 2 limits, or lower limit and upper limit.
From that, we then wrote just a quick script to plot the workspace, and it looked something like this. And so in the real world, and hopefully this works, that looks like this, which we're at the moment superimposing imaginarily over the robot. So I'm just going to keep talking for a second to give us a bit of length in this bit of cut, even though we'll probably cut it.
Once we had established the workspace, we connected up the gripper servo and just got that to open and close. And that's essentially all it's going to do for now.
So now we have 3 potentiometers, 2 controlling the robot position and 1 controlling the gripper. And from this we can build some control software with the hard limits for that workspace. And that's going to look something like this, and we'll probably talk through that at this point.
Going from the top to the bottom of the code, we have the raw values from the potentiometers of link 1, 2 and the end effector shown here. We then map the raw values to the angles that will be used by the servos. So for here it's a direct link between 0 and 1023 to 10 and 140, and then for link 2 it's mapped between 0 and 1023 and then the joint 2 min and the joint 2 max. And then here are just some values or variables that we use to control what motors we wanted to move. This was very helpful when we were debugging the end effector and the link 2 things. We then just printed the mapped values for debugging purposes, and then we just, depending on if we want them to move, we then tell it to move. And that's pretty much it.
For a more detailed explanation of the software, there's going to be a bonus video where we go through it line by line and kind of just explain it in layman's terms.
And we'll link that. We'll link that down below.
Our layout now looks like this, with 2 potentiometers controlling the robot's position and a third one so that we can manually close the gripper without destroying it, as there is no force feedback on the servo, so it can't automatically stop when it's gripping too much.
And then you can see here that as we tweak the dials we can move the robot, and there's quite a bit of skill involved in getting it to move smoothly at this point. And this is all going to actually be in a separate bit of footage that we're going to record over here. But I guess the voiceover can kind of mean that we can mute that footage a little bit as we show it moving. So at the moment that's where we've got with this. It's wired up, the gripper's working, and we've got sort of rudimentary controls. We do have a third video planned for this, where we're going to start working on a third axis, which is a sliding rail, and that's to basically increase the workspace as well as give it sort of more 3-dimensional capabilities. The rails are quite expensive, which is why we haven't started on that yet, but we think we can make something work. In fact, we've got some rails that we've borrowed. So these are the rails, and the idea is to mount this way up with the robot hanging from it. That was always the plan, hence Gantry. We'll also be building a housing for possibly for the robot and for the control box, so that it can be mounted on the Gantry and work basically as intended. In the meantime, check out the video of designing and integrating the control board. We'll be putting that up pretty soon, and it's finally starting to look like a real project.
And thanks for taking the time to watch this. As you know, we are still quite new here and appreciate all the support. Any questions about the project we'll answer in the next video, or do a quick explanation in a short, so ask away in the comments below.
Yeah, catch you soon.
Yeah, bye for now.